Hello, friends. This is the last lecture in this course on software engineering. This will be about software project management. So we will have introduction about software project management, then project management and software engineering methodologies, how they are related, project management for waterfall projects, and then project management for agile projects. Then we will learn project planning for waterfall projects, then agile projects, then project monitoring and control for waterfall projects and for agile projects, then project team management, project customer management, and supplier management. A project is a process through which an objective is achieved by using a series of predetermined tasks. There is a start and end date inside which the project must be started, executed, and finally should come to an end. A project uses a finite amount of resources and time. So, any project like whether a civil engineering project or construction project or mechanical project or software project, generally it is a process through which some objective is achieved using some predetermined task like planned task, and any project consumes time and resources. Project management consists of project planning, monitoring, and controlling so that the project objectives can be accomplished in a planned manner. Software project management is the use of project management processes to build a software product. Software project management uses software engineering processes inside the project management processes for the purpose of building a software product. Some software projects use waterfall based software engineering methodology, while some other software projects use agile based software engineering methodologies. Waterfall methodology is a truly plan driven approach to building software products. Uh, in waterfall project, you create a complete uh, plan for the complete project, and then you execute this project and you build the software product. But unfortunately, a plan driven approach is not suitable for building all kinds of software products. Some of the reasons include ambiguous software requirement specifications, long waiting period, and changing software requirements. So there are some problems associated with software projects because there will be require change requirement request from the customers, and it creates problem in executing the project because project planning was done. It was a concrete project plan, and if they something needs to be changed, then definitely the plan will be impacted, and so execution will go out of hand. Similarly, for these projects, the waiting period is very long. Like, suppose you need to build a large project, large software product, and it will take 1 year of time for understanding, getting the requirement, understanding the requirement, then designing the product, and then writing the source code, and finally testing the product. And only after that, the product can be seen and used by users. So definitely it's a long waiting period. Then in on many projects, the requirements coming from the users is ambiguous. It is not clear to the users what they want in the software product. So due to these reasons, if you make a plan and you encounter these things, then the project will go out of hand during execution. So, waterfall model is not suitable for all kinds of projects. Agile methodology evolved to take care of the challenges which could not be tackled by waterfall methodology. Agile methodology is based on incremental software development to tackle ambiguous software requirement specifications, long waiting period, and changing software requirements. So, On agile projects, you build the software product incrementally. That means you build some software product features in one iteration, say 10 days or 15 days or 1 month, and you have a version of the software product which is fully functional but may have very few product features. Then in the next iteration, you again take some more requirements and build some more product features, and you integrate with the existing software product. So this means you are building the product incrementally. So here you can, using this approach, you can tackle the problems which were associated with plan-driven project management, like if the requirements are ambiguous. So generally, you can do some iteration to make those requirements concrete. Then you can the waiting period is short, like only within 1 month the product features will be ready and the customer can see those product features. Then there there will not be any problem of change requirements, because the requirements are very fresh. Like the project team gets the customer requirements and it builds the product features within a month or within 2 weeks. So there is no need of change requirements. So these challenges are mitigated using agile model, and it works that way. So in agile projects, incremental approach and quick response to market demand define the approach to software development. Project planning in waterfall projects take into account fixing of scope for the project first. So on waterfall projects, since you need to make a concrete plan, you need to fix the scope of work for the project before the project starts. Like you have the complete list of requirements, what needs to be done. So there will not be any change allowed, so that planning can be done for this fixed amount of work. The scope is fixed by finding the size of the software product to be created. The size of the software product to be developed will determine the amount of work to be done on the project. If for any reason the scope, if for any reason the scope is changed, then amount of work to be done on the project will increase. The other aspect about project scope is the quality level to be achieved for the software product. Higher product quality will lead to higher amount of work for the project and thus additional scope. So you can see here in the diagram, you suppose you have the initial scope fixed for the project, and now there are some changes, request coming from the customer. So the scope has changed. So now you have initial scope and then additional scope to due to the change request. So amount of work to be done on the project will increase. This means more work will be needed. That means the scope change will lead to higher amount of work to be done on the project, and this will mean the plan which you created, you plan for the fixed amount of work to be done, now has to incorporate the additional scope, and so the you will need to increase the time or resources required for the project. So on waterfall project, how the planning is done is, first of all you create breakdown structure or WBS, and then you create the project schedule. So in work breakdown structure, what you do is you find out what are the project tasks, and how you can break those tasks maybe in subtasks, and so and you then organize them from the first task when it will start and the next task. So you assign a WBS number for each of the tasks. So for example, in this example, we have WS number 1 for design work, and then WS number 2 for subtask module 1 design, and then WS number 3 for subtask module 2 design, and then WS number 4 for source code. So similarly, you can do the WBS structure you can create, and after that you can schedule like you can provide the start date and end date, and then you can assign the resources for each of these tasks, and you can also find out the dependency like which task need to be started before another task can start. So you can define the dependency. For example, we have provided here that WS number 2 has to be completed before WS number 5 work can start. Like the design should be completed before build or source code writing can start. Once project scope is fixed for a project, then project task need to be defined. It is done using work breakdown structure or WBS. WBS is a complete listing of all tasks which will be planned and executed on a project. The project itself can be considered a large task. This task need to be broken down into manageable and meaningful tasks. Some tasks can also be broken down in such a way that they can be performed in parallel. This will reduce time and thus will lead to shorter project duration. A software design task can easily be broken down into two or more subtasks. These tasks can then easily be completed into parallel. This will ensure that the entire software design work is completed in less time. So here you can see uh, when you are defining the WBS and you are seeing the task. So you can also find out if some tasks can be broken down into two subtasks. For example, we have the complete software design, and you can break down into design for module 1 and design for module 2, and you can do design for module 1 and module 2 in parallel, like at the same time. So some people may be working on designing the module 1, the other people can be working on designing module 2 in parallel, so that total duration will be reduced. For example, the total duration for completing the complete design was 4 days, but when we took them in parallel, so now and each task can be completed in 2 days. So now within 2 days, the complete task can be done. One method which is used in making planning for waterfall projects is Gantt charts. So in Gantt charts are generally graphical. Like you can show the task on say y-axis and time on x-axis, and you design like say model 1 design, and so based on start date end date, so you can uh, you can decide the length or duration of the task. Say module 1 design will be starting at say 1st of February and will be ending on 28th of February. Then module 2 design, when it will be started, say it is starting on 5th of February. So it will be starting later than module 1 design, and it will be say ending later, say on March 5 it will be ending. So you can find out the duration, and you can create this task on this Gantt chart. So similarly, you put all those tasks on the Gantt chart according to what time they are starting and finishing. So this is a good way to show a plan for a project. The WPS is used to create the project schedule as we discussed. The project schedule is created by considering effort required for completing a task, skills matching, and resource allocation, productivity of a resource, resource availability, and dependency between tasks. So you need to consider all these things like how much effort is required to complete a task, then finding out the people who have the skills to do this task and then assigning them to that task, and then finding out the productivity of a person, like how fast the person can do the task, so that the effort can be completed in how much time. And you also need to find if the resource is available or not, and then finally you can find out the dependency between tasks. So like the design should be completed before the source code writing can start, so that dependency you can put in the schedule. If productivity of a resource is to write 20 lines of source code in a day, and the task is estimated to be a size of 100 lines of source code, then the task will run for 5 days. Suitability of skills also need to be considered, as not all people have the same level of skills and experience. Allocation of a resource to a task also depends on economic considerations. If a task has no dependency and there is enough time to complete it, then a lower skilled person can be assigned to this task as it will be cheaper. So, uh, from financial point of view, if you want to save money, so you will find out a task which is not critical, and critical means the task can be completed in more time than planned, and in that case you can put a person with less skills or experience, because the charge will be lower for you to do the task, so you can save some money. But critical tasks should always be assigned to best available person. But the critical task where if the task is getting delayed, then the project will get delayed. In that case, that task should be assigned to a person who is very good on the job. For example, a critical task here, like say, uh, in this Gantt chart, you can see there is some buffer for completing, say, module 2 source code building from design. So the design task can be given to a less skilled person, because from this graph you can see there is some time gap. Okay. Similarly, for module one design and module one build, they are linked to each other, but there seems to be some gap. So some tasks you can assign to a person who is who is less skilled but will charge less. So it will be cheaper to do the same job with a less skilled person. Then thinking about the dependency, if a task needs to be completed before another starts, then scheduling should consider this dependency between these two tasks. Similarly, if a resource is available for a certain period, then the task on which this resource is assigned needs to be scheduled inside this time window. So you also need to consider resource availability. Like if a resource is available, uh, then you need to find out if the task can be done in that time window. If it is possible, then you can assign that resource. Otherwise, you will find another resource which will be available to do that task. When all schedule constraints are resolved, then the project schedule can be drawn. So all these constraints you need to consider while creating the project schedule. A project schedule can be drawn either in form of a schedule table or a Gantt chart. So we saw that Gantt chart, and we also saw that table where you can have these WS numbers and then task. and the start date of the task, end date of the task, and who is assigned that task, and then any dependency. You can also show on a chart in a tabular form, or you can use a Gantt chart. A Gantt chart is more useful as it depicts all tasks in a graphical manner, which is easier to understand. Finally, the project cost can be calculated by adding cost for all tasks. The labor rate and the time a resource works on a task will give the cost for each task. So you can find out the task, how much a task will cost to complete, like finding out the rate of the person who is assigned that task, and how much time of the person is required on the project to complete that task. And then you add all those tasks, cost for each task, so you will get the total cost for the complete project. In a project schedule, some buffers are also placed to take care of emergencies or project risk. So you also keep some buffers between tasks to take care of emergency. Especially you keep buffers for critical tasks, because if a critical task is getting delayed, then the entire project will get delayed. Critical path method or program evaluation and review technique, so also known as CPM slash PERT. CPM is critical path method. PERT is for program evaluation and review technique. Is used to create the project schedule. In this method, all tasks are placed in a line as per their start and end dates. The shortest line from start date of the earliest task to the end of the task, latest task, becomes the project duration. So you can find out the project duration when you lay down all the tasks uh, in a line where the earliest start date of the earliest task is placed first, and then you keep putting the task one by one on this line, and then finding out the finishing date or ending date of the last task. So earliest start date and latest end date. This duration will give you the duration for the project. Once a project schedule is finalized, then it needs to be frozen. A frozen project schedule is known as a baseline project schedule. So you need to create a baseline. Like once you finalize the schedule, project schedule, and you froze it, that means no changes are not allowed in this project schedule. So this is known as a baseline project schedule. When a project is executed, it is tracked against this baseline project schedule. So now when the project starts execution, in that case, all the tasks will be tracked against this baseline project schedule. Now let us come to project planning for agile projects. So on the agile projects, in the diagram given here, uh, you can see on the top is project plan, and inside a project plan you can have major release plan 1, major release plan 2, etc. Then inside a major release plan 1, you can have time box plan 1 and time box plan 2, etc. Then inside a time box plan you can have daily plans, like time box plan is spanning for 10 days, then you can have 10 daily plans. So this is how the planning works. Essentially, for agile projects, you never create a project plan. What you create is the daily plans and time box plans. And whenever a time box plan completes, the next time box plan will start. And say you have uh, time box plans for 10 days each, and you have three time box plans for a major release. That means a major release can happen in 30 days. So this is how project planning is done for agile projects. Even though agile projects are not planned driven, nevertheless some planning is needed to execute these projects. On agile projects, planning has shifted from project level to lower levels. On agile projects, a project plan is divided into major release plans. A major release plan is then divided into minor release plans, also known as time boxes or iterations. Then each minor release plan is divided into daily plans. Detail and firmness of a plan depends on at what level it is located. A major release plan is fuzzy and tentative. Thus, a major release plan date is not firm. The time box plans are firm as far as dates are concerned. Like when you created time box plans for a major release, so the first plan will be firm, like it should be completed at certain date, and the next plan may be tentative because uh, uh, it depends on finishing the first time box plan. But scope for a time box is not firm. So generally, you create you assign dates, start date, end date for each time box plan. But the scope you never fix for time boxes. It is because the time is fixed. Like say in 10 days, you should the iteration or the time box should complete. But in 10 days, how many product features need to be developed is not fixed. So you can either fix the scope or fix the timelines. So if you are fixing the timelines, you are not fixing the scope. So in that case, you can assign importance of product features. Like say you have four product features, and you assign say product feature number one is important. Product feature number two is important. Product feature number three is not so important. Then again, for product feature number four is not so important. So when the time box starts, first two product features you will develop, and in say the time box is for 10 days. So and you have time, then you go for creating the working on the creating the product feature number three, and you still have time, then you will work on product feature number four. And in case you do not have time, in 10 days you can finish only the first two, then those remaining product features will be taken in the next time box. Then daily plans are made for achieving tasks to be completed for a day. Then you also have daily plans where the project team will meet and discuss what things they will be doing in the day, what work they will be working in the day, and if they have any problems, they can discuss and resolve them. The daily plans are thus formed in our respects. So in the daily plan, generally it is the amount of work to be done is fixed because it is a very detailed plan. Time box is a concept of to pack all project tasks inside a tight and fixed schedule. The scope for a time box is not formed. All project tasks are given a priority level. High priority tasks are done first and completed inside the time box. If time permits, then less priority tasks can be taken. If time does not permit, then these less priority tasks can be taken in the next time box. Traditional project planning techniques like Gantt chart, PERT, CPM, Goldratt, critical chain method, etc., do not work on agile projects because uh, essentially these tools like Gantt charts or PERT, CPM or Goldratt's critical chain method, they depend entirely on plan-driven approach. But in agile projects, they are essentially not plan-driven. They are essentially based on taking care of changing requirements or in ensuring that the market demand product features which are demanded in the market are developed quickly. So in that case means you are not planning like which product features will be taken in say time box number three. When you actually reach the time when you need to start time box number three, the based on the market feedback, you will be developing the product features in that time box. Okay. Now, when the now let us discuss how project execution monitoring and control is done. So the Gantt chart which we drawn earlier, which had module 1 design, module 2 design, module 1 build, and module 2 build. Now they are being tracked. So when you track uh, a project, then the task, the actual working, like actual start date and actual end date, will be different from the planned start date and end dates. To show this difference, you plot the actual working of a task with dotted lines. You show this, like here we are showing module 2 design. The actual start date and end date are different. So this is the actual, the dotted line is showing the actual progress of a task. Similarly, we are showing module 2 build with dotted lines. This means this is the actual progress of the this module 2 build task. So this is how you track, monitor and control a project in waterfall projects. Project monitoring and control is needed when a project starts executing. So for waterfall projects, we already discussed that the tools like Gantt chart and critical path method, CPM PERT, and Goldratt's critical chain method are used. And one more method is earned value management (EVM). So these tools are used to monitor and control a waterfall based project. On a Gantt chart, if a task is slipped from its schedule, then it is shown in dotted lines. The actual start date and end date are also shown. Goldratt's critical chain method uses buffers for critical tasks. A critical task is a task which, if slipped, will result in slipping of the project schedule. For these critical tasks, the buffers are monitored carefully. If a critical task slips and consumes more than 50% of its related buffer, then it is considered that the project schedule is in danger of getting delayed, and some action need to be taken to ensure that the project schedule does not slip. So critical chain method is in critical chain method, uh, for all critical tasks you assign some buffers, and uh, you actually do not measure the task progress for this critical task on critical chain method. Instead, you only see the buffers, like the actual working of the task. If it is reaching inside the buffer zone, and it is consuming the buffer time, and then you find out that it has come to say 40% consumed. So only then you get worried, you start worrying, and then you need to find out ways to fix the problem. Like you ensure that before consuming all the buffer, the task is completed so that the project is still on track. So here is we are showing the buffers in this diagram. So say task one is a critical task because there is some buffer assigned. Then task 3 is again a critical task, and you are assigning a buffer. And on this diagram, you are also showing task 4, which is a parallel task. So this task is actually not a critical task, and it can be completed at any time. There is no dependency with other tasks. But you can see there is a dependency between task 1 and task 3, and some buffer is assigned because they are critical tasks. Similarly, between task 3 and task 2, you are assigning a time buffer. When a project plan is created, time buffers are introduced in the plan. These time buffers are provided after critical tasks for providing cushion if a critical task slips. Some amount of these time buffers are consumed when such a critical task slips. Thus, even though a critical task slips, still the project plan is still on track thanks to these time buffers. In fact, in Goldratt's critical chain method, critical task progress is not even measured. It is the time buffer provided for this task which is measured. If such a time buffer is consumed more than a predefined value, then the manager must act and take some action to keep the project schedule on track. Now let us discuss earned value management. So before discussing earned value management or EVM, you need to understand two concepts: schedule deviation and cost deviation. In other project planning and monitoring systems like Gantt chart or CPM, we never consider the cost parameters. But in EVM, cost is also tracked, and that is why it is different from other techniques. So, how we find out the deviation, like for example, how to find the schedule deviation. So, we can draw diagrams like a schedule of work. So, in the schedule of work, there will be three things which will be drawn. One is total schedule of the planned work. So here it is in black. It is shown the total schedule of the planned work, and then progress schedule percentage of planned work. The uh, suppose at a given point of time, what was the planned schedule of, of the work. So percentage, what percentage? Like suppose here, the gray bar is showing. Suppose it 60. It is showing 60% of planned work at this time. Suppose the total task was planned for 10 days, and on the sixth day you want to measure the actual progress. So that means 60% planned work was targeted at this stage, and you want to measure now the actual progress. And in the white bar, it is showing the actual work. So here it is showing actual work is completed, say around 50%, but the planned was 60%. That means the task is slipping by how much percentage. So that you can find out from 60% and actual is 50%. So there is a 10% deviation in the project. Is a schedule deviation for this task. And the other parameter is the cost deviation. So again, you have the total cost of planned work, like what was the budget for this task, which is shown in black bar, and then in gray bar it is showing the uh, actual work, how much work was done for at a time when measurement was taken for this task, and the white bar is showing the actual planned work. Sorry, the planned work, how much work should have been completed by this date. So, for example, here it is showing that actual work had been done, say 60%, but the actual cost was 60%. Actual cost happened 60%, but planned cost was say 50%. That means there is a 10% deviation. 10% more expenses occurred on the project. So the cost is more, but it does not say if the project work was done uh, more. Even though the cost was more, it doesn't mean the work was also done more. So that from where we get that, we get that from the previous diagram where we are measuring the schedule. So how much work, actual work was done. And here we are showing how much actual expenses occurred for completing that task at this level. So in EVM, this is very important to understand. And EVM is one of the popular methods for monitoring and controlling projects. In EVM, both schedule and cost are tracked for projects. There are two concepts of schedule of work and cost of work which help. in understanding how EVM works. Schedule of work is related to the actual amount of work done versus the planned amount of work in a time period. Cost of work is the actual amount of cost incurred versus the planned budget in a time period. Related to these two concepts are schedule variance and cost variance when the planned work or cost is different from the actual results. These two concepts need to be related to each other to understand EVM. It can happen that actual cost incurred in a time period is more than planned budget, but the amount of work done in the same period is less than planned. So here is example of a EVM diagram, how it is sketched. Like in this on the y-axis we have budget. So budget is some figures are shown like $20,000, $60,000, and $100,000. And on the x-axis we have the time duration, like starting from project. Say project is starting in January, so we have months assigned here: January, February, March, April, May, June, etc. And we are now drawing the progress of the project, and before that we already may have drawn the planned figures, like we have in this diagram we are showing one as planned value means planned cost, like starting from uh, 20 $20,000, and we are going above $100,000. So there is a planned value, and then schedule, planned schedule. Okay, this one, this figure, and based on this, the differences, there may be differences between the progress of the progress project progress and cost progress. So we will end up having variances. So there will be cost variance, like compared to actual cost at any point of time, and planned cost. Okay, and then similarly we can have schedule variance, seeing from the planned value and actual value. So based on these variances, you find out if the project is on track or not. So this is how in EVM the projects are tracked. Apart from schedule and cost, a project manager also needs to manage the project team. Project team members' performance on the project is crucial for the success of the project. A motivated and success-driven project team makes all the difference on the project. If the performance of a team member deteriorates, then the entire project will get impacted. A delayed task will lead to delay in the entire project work. Thus, the project manager must keep tracking each project task and also keep a track of performance of each team member. So, project manager has to keep tracking the project schedule and project cost. At the same time, he also has to keep an eye and as to how the team members who are doing on the project. If a team member is lagging behind due to some personal problems or some other problem, skill level is less than required, etc. So, in that case, the project manager must take some action. Maybe he may assign another resource for that task, or uh, do some ask the team to do some overwork to complete the task in time, etc. And he also need to keep motivating the project team so that they are motivated, and they will be doing the work to ensure they get all the work get completed in time. A project manager is also responsible to keep a good rapport with the customer. Meeting customer expectations is important. Customers want timely delivery, visibility into the project, and good quality of the software product. If something is going wrong on the project, then the project manager should be able to explain why it is so and how it will be corrected to the customer. A satisfied customer will make the job of managing the project easier for the project manager. So, if the customer is not happy, then definitely the customer will be complaining, and the project manager will have difficulty in managing the project. So a good report is required with the customer, and the project manager should be able to explain everything about the project. If something is going wrong, then why it is going wrong, and the project manager should have a plan and should explain to the customer how uh, the the thing which is going wrong will be corrected, and how the project will go smoothly, and there will be no delays, etc. So managing customer is also one aspect of the job of a project manager. If a project has suppliers or service providers or outsourcing partners on the project, then the project manager also needs to manage them. A good service level agreement should be in place so that the service providers are bound by this agreement to deliver the expected services at the right time. A part of the project will be delivered by the supplier. Definitely, the supplier has been assigned to some project task, and supplier will be completing. So, the supplier may have some people engaged who will be doing that part of the project, and there will be a service level agreement with the supplier to ensure that the supplier will deliver the agreed deliverables on time. The project manager needs to work with the supplier to ensure that this part of the project work is delivered by the supplier on time. A good arrangement with the supplier should be that there is an open communication channel with the supplier, and the project team gets updates from the supplier on daily basis. So communication with the supplier is important, and the project manager should ensure that the project team gets daily updates from the supplier as to how the work is going on and what progress the supplier team is making on the task assigned to them. This will ensure that there are no misunderstandings or communication gaps which may result in rework on any project work. So this was all about software project management. So with this, I am ending this course, and the next thing I will take is I will take a case study where we will build a software product. So we will have first we will understand the requirements. What are the requirements for building that product? Then we will design components of the product. We will design the classes, and finally writing the source code, and then testing the product and see if it is working. So all those exercises will be totally hands-on, and it will be interesting to build a software product after learning on this course. So next time we will meet, we will discuss about this case study, and how the product will be made. So thanks for your time, and bye for now.